Hello everyone, my name is Rabi Abdelkarim and in this talk I will present our journal first paper that is published in the IEEE transaction on software engineering. And the paper is about using a machine learning approach to detect the CI skip commits. This work was done with collaboration with Suhaib Mujahid and Imad Shihab from Concordia University. Let me start by saying that nowadays software developers are encouraged to build fast and build often. The main enabler of that is the use of continuous integration, or CI. CI automates the compilation, building, and the testing process. But it is not all good news. In reality, running CI pipeline can take a long time, especially for large projects with a big number of test cases that need to be run. As a result, CI can become a bottleneck since developers need to wait for the CI process to finish. Therefore, the question that we ask in this study is that, do we need to run the CI process on every commit? In particular, the commits that perform cosmetic changes to the source code. One specific example of such cosmetic changes is this commit in the GeoSurfer GitHub repository. As you see here, the commit only adds an empty space to format the source code. However, running the CI process for this commit took around an hour and a half to finish. Therefore, the question that raises naturally for us, do we need to run the CI process on every commit? In our prior work, we studied commits that can be CI skipped, and we contacted developers to understand their perspectives about skipping the CI process for some commits. Overall, the developers highlighted that it is a good idea to skip commit that unnecessarily kick the CI process. And there are two main points mentioned by the developers and explained why developers want to have such a technique. The first point is to save some resources required to run the build. And the second reason is that developers don't want to block up the queue for other developers who are working on other tasks. Therefore, the main goal of this study is to propose a technique or a solution to help developer identify which commit to CI skip with a good accuracy. And basically, we propose to use machine learning approach. At a high level, to use a machine learning and train a classifier, we want to have a label dataset. So what we actually did is that we went to GitHub and looked for Java projects that use Travis CI where the developers CI skip some of the commits in those projects. We do this since we want to make sure that developers explicitly label the commits, which ones are CI skipped commits. In total, we selected 10 projects. We cloned these project repositories and mined their development history. For each individual commit, we mined its commit message and looked for the keyword CI skip, which is an indicative of CI skip commit used by Travis CI. And this is how we constructed our dataset. Once we collected our data, we then conducted our experiment to validate our approach. We first analyzed the development history of the selected 10 projects and extracted a comprehensive list of features. Then it totally makes sense. We had all these features that we can use machine learning techniques to determine the CI skip commits. And in our study, we use a decision tree classifier, and then we use the well-known evaluation method, which are precision, recall, F1 score, and the area under the curve, AUC. Since we propose to use machine learning techniques, we need to have a set of features that capture the characteristic of CI skip commit. We thought about these features and looked in the literature. We extracted a comprehensive list of features. Basically, we extract features that give an indication of a CI skip commit. We thought we have grouped these features into 5 dimensions. Due to time constraints, I will explain 3 of these dimensions. First dimension is the diffusion feature. The main idea about diffusion features is the fact that if a developer has to change many things across the system or the project, this can give an indication that this commit is difficult and it will not be skipped. The second dimension of features is the size dimension. We looked at feature related to the size because if there is too much code change, this can can be an indicator of an important change, or if the change code is very little, this can give an indication of a CI skip commit. The third dimension of features are rules related to CI skip commit that we devised in our prior work. These features are rules extracted based on analyzing explicit CI skip commits marked by developer. We looked at these rules since they can be a good indicator of CI skip commits. In total, we extracted 23 features. Now we build our classifier. The first thing we looked at is the accuracy of the proposed approach. So the first thing we did is actually compare our result to a baseline, and we do this to put our result in perspective. Basically, our baseline is the performance achieved by the rule-based technique we proposed in our previous work. These box plots show the distribution of the precision, recall of one score, and the AUC value achieved by the baseline. And when we apply our classifier, we were able to improve the precision, recall, and F1 score. And our results also show that we were able to improve the AUC values from 0.1 to 0.91 compared to the baseline. Overall, this means that our approach performed very well. Since we know that our approach achieves a good performance, now we want to know the most important feature that determine these CI skip commits. Basically, we perform top node analysis to identify the best indicators or feature for CI skip commits. In our study, we built a decision tree classifier on the dataset from each project. In a decision tree classifier, the most important feature is the root node in the tree, and the less important features will be placed in lower levels of the tree. In this example, the top node contains the feature type of files it changed, which means that this feature is the most important in this tree. So we count how many times a feature appears in the top node in all created decision tree in our studied 10 projects. As you see here, there are mainly 3 features tend to be the most important features in determining the CI skip commit, which are the number of developers who previously changed the modified file. And when we investigate, we found this is because in some projects, there is one developer who is responsible for updating the README file, for example, and any change to the README file is considered as a CI skip commit. We also see that the CI skip rules and the textual feature provide a good indication of CI skip commits. In the last part of this study, we looked at building a general classifier. In our study, what we did before, we built a classifier specific for each project. But in this experiment, we want to build a general classifier that can be used to determine the CI skip commits for any project, not just within a specific project. Therefore, in this experiment, we trained classifiers on the data from all projects except one in our dataset, and trained the classifier on the remaining one project. We applied this process in all the 10 projects in our dataset. These box plots show the distributions of the precision, recall, F1 score, and AUC. We found that when we built our general classifier, we achieve a median AUC of 0.7. Overall, our general model shows the promising results. To conclude this presentation, I first motivate the need for skipping the CI process for some commits. And then I presented our approach of using machine learning to detect CI skip commits. And I show the performance of our approach and the most important features in detecting CI skip commits. Thank you for your listening.
Hi, everyone. Thank you, Rabe Abdelkarim, for presentation. I welcome everyone to the questions, and we already have 2 questions. Nameng is asking, how is this compared with related ML-based tools, for example, a cost-efficient approach to building in continuous integration?
Yeah, hi everyone, and thank you for the question. Yeah, I mean, we are basically targeting the same We have the same goal. I mean, try to improve the efficiency of the continuous integration. And basically, in our case, we are looking for identifying commits that can be CI skipped. And once we do that, I mean, the next step is just to see the build that basically contain only commits that can be CI skipped, and then basically skip that build, the whole build. And the other paper just focusing on the build as overall of the build, the efficiency, the skipping the build that you know the result of it. Yeah.
Question for the CSK paper. How did you evaluate the effort that can be saved by CI skipping some commits for the developers?
Yeah, this is an interesting question. I mean, this question in our previous paper, the first one, we start at the beginning by analyzing commit that developer explicitly CI skip them, and then we come up devise a rule-based technique. And using that rule-based technique, basically, we look at how much, for example, once developer skipping commit, how many of these build can be skipped. And we found almost 15% of the build can be skipped. So we use two measures. One is the number of build that can be skipped and save for the developer to wait and see the result. Also, we look at from the point of view of the cost, and this time, in this case, we look at the time. How long does it take for a build? And I don't remember the exact on average for the project that we analyzed, but we did the saving time, right? When you build, it takes some time. So for some application, can take even an hour just to build and run the test cases for that build. So we measured in two cases: saving number of builds and saving the time for the developers. Yeah.
Any more questions for Rabe? I don't see more in the chat while people are still thinking. I have some questions for you too. Mm-hmm. It looks like you've done a lot of analysis, Rabe. It's quite impressive, the amount of analysis that you've done. Can you comment on the implications for future CI? Like if we were to improve future CI tools in the future, can anything be done so that developers provide this information live when they make commits towards labeling this data for you, so that this learning can be continued?
Yes. So basically, when we did the manual analysis and look at the cases of developer CI skipping, we find many cases. For example, some of them are really cosmetic and really trivial changes that can be skipped. When, for example, they change README file, they formatting the code, all of these can be automatically to some degree. But in other cases, there is in cases where we find developer changing code and they skip the build. So one of the things we did in our previous paper, and basically we develop a tool that automatically detect which commit can be CI skipped, and basically when you try to commit the code or push it to, for example, to GitHub, it will recommend you and say basically, hi, this build can be skipped. So this is the one of the a practical implication or practical tool that we have. But this doesn't mean it automatically will skip, but it will say for the developer, you want to skip this or not. And the
developer can confirm. The developer can confirm, right?
Exactly, yes. Yeah. Because it's really for the developer, sometimes even you change README file, but previous build, for example, it was failing. Developer need to make sure, even when changing this, need to see a green build. Yeah, this is the thing. Yeah, you did.
And just a follow-up question: it looks like your model can be continually improved
during
this live confirmation.
Yes, I mean, if you do feedback loop, for example, adding more data, this is this is a way to improve the model. Yes.
Sounds good. We've got two more questions from Sarah and Leandro. Sarah is asking, based on your cross-project analysis, what distinguishes skippable commits in general?
I mean, again, as from looking at the data, looking at the cases, as I said, for example, if these commit can be really trivial and cosmetic, they do cosmetic changes, they can be skipped. For example, as I said, for example, changing README file, changing, for example, images. For some applications, they update the logo of their applications. These can be cases where they can skip. Yeah.
Sounds good. Leandro is asking, what are the consequences of CI skipping a commit that should not be skipped? Could that lead to extra effort needed later once the commit is actually made, as other changes may be implemented assuming the original code?
This is a very interesting question, actually, and this is something we thought about, and for sure, for example, you have like the previous, let's say the previous build was failing, and the next build you skip it, or our tool or our model recommend to be skipped. So basically, this will add up, right? Adding more code. So this is something we need to look at it, and this needs some research to see the cost of applying these CI skip in industrial or with developers, or looking at even analyzing the data. Yes. But
yeah, that's actually a good lead into a follow-up question. Seung-Jun Chung, he's asking, do you have any plan to apply it in the practice? I think he or she's referring to more empirical studies.
We visited a company in Montreal during that time, and they were really excited about the tool, but it was, I didn't know. If I find someone to be interested. One important thing also, we was contacted recently by a developer from Google, and what they did, they replicate our tool using I think the bash. I didn't know, maybe they want to incorporate it, but he was interested in incorporating with us.
Yeah, I guess those empirical studies, if you were to do perhaps even interviews, they could give you insights as to for characteristics of skippable or non-skippable commits, right? Like we were talking earlier, because there's a follow-up question from Fiorella. Do you have any idea of the characteristics of the commits that your approach classifies as skippable commits while they should not be skipped?
Yes. So one of the things that we assume and we look at is that assuming the application that we analyze are pure Java applications, right? And we analyze based on that, like even the code, some of the rules are really based on Java language, but based on that, for example, that commit never change Java code, let's say. But in reality, these applications, they have some JavaScript, they have some front-end development. So they have, for example, JavaScript. And basically, our analysis, we wouldn't really look at these type of changes. So, for example, if you change other part of the system rather than Java, for example, you're changing some build. For example, the updating the build, for example, they update a dependency to a minor version or a batch. We assume this should be skipped, but in reality, it doesn't. Yeah, I mean, there's some cases. Yeah, I agree.
It sounds like a worthwhile future research is to characterize these CI commits that could be skipped or not could be skipped.
In the paper, we have a discussion section, a small discussion section. But yeah, this is an interesting thing. Yeah, we should do some research and look at it. Yeah.
Yeah, just a heads up. This is the last question. We have 35 seconds left. Darius is asking, do you think that adding features based on AST could be useful?
We look at the rule base, but we never use AST. We use like some regular expression to look at the type of changes, all of these. I mean, the timing and AST. I think AST. I know some other research they try to do that AST, but they never did it in the context of CI skip. But I think it's gonna be improved. Yeah, my opinion. I need some research again to see that. Yeah.
Thank you very much, everyone.